Okay.
Perfect.
So the first one's a triplet.
The first one is a triplet. Good.
The second one's a a sextet.
Yes.
And then it's a quintet.
Yes. Hey, let me call you back. Okay, bye.
And then the other one's a quintet as well.
Yep.
And then it's a triplet.
Yes, exactly. So that's a good start. And you know that these words represent how many lines we have?
Yes.
Perfect. So let's start here. We know that there's a carbon here.
Mm-hmm.
We need to figure out how many hydrogens are connected to this carbon. The way that we do that is we look at this right here. This 2H is telling us there's 2 hydrogens connected to this carbon that we're talking about.
Okay.
So this is saying this should be CH2. And we can confirm that in a minute. So now we look up here. A triplet represents what number?
Like neighbors? We did -1.
Why did we do -1?
So we can find out how many hydrogens are in your carbon.
How many neighboring hydrogens are connected to this carbon?
Okay, neighboring.
Cool. So now we're looking at the neighbor of this CH2. Now we know that there's only one neighbor because it doesn't have any molecule on the side. One has a molecule on the side. Now if it says that we have 2 hydrogens connected to this CH2, how many hydrogens should be over here?
Also 2.
Cool. This would be a CH2. So that's how we find out how many neighbors we have, and we can confirm now by looking at this again. This is telling us this carbon that we're looking at just below should have 2 hydrogens on it.
Mm-hmm.
They have 2 hydrogens?
Mm-hmm.
Perfect. Awesome. So now we go back up to the lines.
So now we're going to do 6 minus 1.
6 minus 1 equals
5.
Cool. So this is saying this carbon should have 5 neighboring hydrogens on either side.
So it's going to be CH3.
How do you know that it's CH3?
Because it's telling you how many, the 5 is telling you how many neighbors it's going to have.
How many hydrogen neighbors it should have. And we know that it's CH3 on this side, because if you look at this side, we already have 2. So if you do 5 minus 2, it's equal to 3. So this should be equal to CH3.
Okay.
Cool. So now we figured out the neighboring hydrogens of this carbon. Now let's look here to confirm that this is CH3. This is a 3. So if we look here, this says this main carbon should have 3 hydrogens connected to it. Does it have 3 hydrogens?
Yes.
Perfect. Awesome. Now we can look at the neighboring hydrogens for this carbon. So it says that we have a quintet, which is 5. -1 equals 4, which means we should have 4 neighboring hydrogens. How many do we have on this side?
2, so we need CH2. And how do we confirm that? Based off the thing that we just did. And we look at that, the 2H under.
Because this is telling us this carbon that we're looking at should have 2 hydrogens. And this does have 2 hydrogens, so that's good. Now, we want to look at this. This is also quintet, so it's 5 minus 1 equals 4. That means there should be 4 neighboring hydrogens on either side. How many do we have on this side?
3 is going to be CH.
Perfect.
And how do we confirm that? By looking at 1H, and that's how we confirm that.
So this carbon should have 1 hydrogen. And then we can look up here, it says it's a triplet. 3 minus 1 equals 2, which means it should have 2 neighboring hydrogens. Does it have 2 neighboring hydrogens? Cool, then this is our molecular formula, or whatever.
Wow, all right.
This is the answer.
Thank you.
You're very welcome.